If you're an engineer who deals with corrosive media, you know that system reliability isn't just a goal, it's everything. Today, we're going to break down a complete engineering approach to getting these aggressive fluids under control and making sure your operations are secure.
Right. This is the question that probably keeps plant managers and technical directors up at night, because the answer isn't just one simple thing. No, it's a whole cascade of critical failures that can bring your entire operation to a grinding halt.
And the consequences are, well, they're severe. We're talking about unscheduled downtime that just completely wrecks your production targets. We're talking hazardous leakage, which puts your people and the environment at serious risk. And product contamination? That can ruin entire batches. It all adds up to a huge operational risk that hits your bottom line and your safety record hard.
Now look, these aren't just some theoretical risks. They're daily battles being fought in very specific industries. So let's dive into 4 of the most demanding environments out there and see why a one-size-fits-all approach just doesn't cut it.
First up, the new energy and battery materials sector. When you're producing something like lithium batteries, the whole game is about purity. I mean, even the tiniest, slightest trace of a metal contaminant can completely compromise the quality and performance of that final battery.
So the requirement here is absolute. Zero metal contamination. Period. Think about it. When you're handling super corrosive electrolytes, even microscopic metal ions leaching out of a valve or a pipe can contaminate the whole batch. That can create internal short circuits that kill the battery's performance and its lifespan. Your entire fluid system has to be chemically inert, because any metallic contact is a potential point of failure.
And here's what that solution looks like in the real world. This is a fully installed PFA line system inside a lithium battery plant. That PFA, or perfluoroalkoxy lining, it basically acts as a perfect impenetrable shield. It completely isolates that high-purity media from any metal surfaces, stopping contamination before it can even start.
Okay, let's switch gears. In the world of fluorosilicon and fine chemicals, the challenges are a little different. Here, engineers are basically fighting a two-front war. You've got high-permeation media trying to seep into the lining, and you've got these wild temperature swings that can cause blistering or even vacuum collapse.
So what's the payoff for getting this right? Well, this one number says it all: 3 times. A 3 times longer service life compared to your standard industrial valves. And that's achieved with advanced lining tech that's built specifically for these harsh conditions. That has a direct impact on your maintenance cycles and, of course, your operational costs.
All right, let's scale up. Way up. In huge petrochemical complexes, everything is bigger: the pipes, the pressures, and definitely the stakes. Here, the engineering challenge isn't just about corrosion. It's also about meeting really strict international compliance standards, whether that's ANSI, DIN, or JIS.
And yeah, this image gives you a real sense of that massive scale. We're talking about comprehensive fluid control packages for things like downstream ethylene processing. It requires everything from these huge large-bore lined valves to incredibly complex piping layouts, all of it designed to work together as one single reliable system.
And for our last stop, let's go to the heavy chemical industry. Here, the attack isn't just chemical, it becomes physical. The main enemy isn't just corrosion, but the constant, grinding wear and tear from abrasive slurries and solids.
So how do you fight back against a two-front attack like that? Well, it takes a dual solution. You see it here. A thick-walled PTFE lining provides that rock-solid chemical resistance, while specialized materials handle the physical erosion from the solids. The whole system is just built from the ground up for maximum uptime.
Okay, so we've just dissected the unique problems in 4 very different, very demanding industries. Now let's pivot and talk about the unified solution that connects them all. It's really about taking a system-wide approach to achieve total reliability.
And it's really a 4-part strategy. See, this isn't about just selling a single valve. It's a complete system designed to deliver on 4 critical outcomes: absolutely prevent leakage, completely eliminate any chance of metal contamination, significantly extend the service life of the entire system, and of course, meet or even exceed global standards.
So that's the strategy. But, theory is one thing. Field-proven performance is something else entirely. Let's get into the final section here and look at the real, tangible proof that builds trust with engineers all over the world.
Let me be absolutely clear on this point. Everything we've been talking about, it's not based on some lab concept or a theoretical model. These are installed, operational systems that are running right now in real industrial projects across the globe.
And here's the visual proof. You're not looking at diagrams, you're looking at real project sites. These photos show the solutions fully integrated and performing in some really complex, really challenging environments. This is where the engineering truly meets reality.
Hundreds. That one word represents the depth of that real-world experience. We're talking hundreds of successful on-site installations worldwide. Every single one was a unique problem that got solved. Every one of them is a testament to the system's reliability.
So what's behind all that success? It really comes down to the engineering support. Full piping layout consultation, deep expertise in material selection, and just an unwavering commitment to quality that exceeds tough standards like API 598 for valve testing and ISO 1584-1 for emissions control. That level of quality assurance is how you build trust.
So if there's one really important thing to take away from all this, it's that to truly secure your operations, you have to think beyond the individual components. You have to focus on the entire system.
And this quote just captures that philosophy perfectly. Your system needs more than a valve, it needs a solution. It's really a shift in perspective, right? You're moving from just buying a part to implementing a complete, comprehensive strategy for fluid control and system integrity.
So, if you're grappling with these kinds of challenges in your own high-corrosion environments, the path forward isn't a sales pitch, it's a technical discussion. This is really an invitation to share your project specs with a team of engineers and start designing a complete solution that's tailored to your exact needs.